On no other medium except this WebEx room shall we be sharing the feedback form link for the certificate of participation generation. I request all the participants to kindly ensure that please directly join this WebEx room in huge numbers and earn yourself a certificate of participation at the end of this webinar. Dear participants, I once again repeat, at the end of the webinar, we shall be sharing a feedback form link with all of you. Filling of this feedback form link is important for all of you because once you fill and submit the same, you shall be earning yourself a certificate of participation. You shall be generating your own certificate of participation for this webinar. So kindly ensure that you fill in the feedback form. Please fill in the details of the feedback form carefully so that you do not make any mistakes in the same. Any mistakes you make in the feedback form shall directly be reflecting into your certificate of participation. It is a certificate of participation, so kindly ensure that your name of the organization you fill in such a way that it fits into one single line. In case you have long organization names, you can put in short forms for the same so that once it goes into your certificate, there is only space for one single line on the certificate, so it fits into the same. Professor M.N. Huda, sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management, has already joined us. Good evening, sir. Welcome to the webinar.
Dr. Ritika, good evening, everyone, and please start.
Yes, sir. A very pleasant evening to all distinguished panelists and participants. Bharati Vidyapeeth Institute of Computer Applications and Management, BVICAM, in association with Computational Intelligence Society, CIS chapter of IEEE Delhi section, Computer Society, CS chapter of IEEE Delhi section, Technology and Engineering Management Society, TMS chapter of IEEE Delhi section, System Man and Cybernetics, SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Site Standing Committee of IEEE Delhi section, Region 10 of IEEE with the Association of Computer Society of India, Institute of Information Technology Professionals, IITP, ISTE Delhi Region, and IETE Delhi Center as technical collaborator. Welcomes you all to the IEEE IETE BVICAM Technical Lecture Series on Authentication and Authorization in the Digital Age. According to Heather Brook, it used to cost money to disclose and distribute information. In the digital age, it costs money not to do. This quote itself is sufficient to set the importance of this topic today. Authentication and authorization play pivotal roles in bolstering the security of SaaS businesses and enterprise applications, managing diverse user data, including employees, external partners, and customers, each requiring distinct access levels adds complexity. Traditional username password authentication, while widely used, faces challenges due to password susceptibility. Multi-factor authentication addresses this by adding layers of verification through methods like biometrics or mobile app-generated codes, significantly reducing unauthorized access. Authorization complexities arise from the need of fine-grained control over user permission as enterprise applications support complex workflows, striking a balance between granting adequate privileges for efficient task execution and safeguarding against unauthorized actions is an ongoing challenge. Role-based access control system address these concerns, allowing administrators to define roles and regulate user access precisely. This webinar today will discuss its all-around perspective, including the real-time issues and challenges. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome Professor M.N. Huda sir, Director, Bharati Vidyapeeth's Institute of Computer Applications and Management, BVICAM, and Executive Vice Chairperson, IEEE Delhi Section, to address the participants with his inspiring words.
Am I audible, Dr. Ritika?
Yes, sir.
Yeah. So good evening, one and all. And at the outset, let me take this opportunity to welcome today's valued speaker, Mr. Girish, for this 145th lecture series of IEEE, IETE, CSI, BVICAM weekly Saturday evening webinar series. I also take this opportunity to welcome all my friends from various professional societies and participants who have joined from different parts of the country and students as well. So thank you so much for having joined this 145th webinar series. Dear friends, as all of us are aware that this webinar series was started long back in May 2020 in the backdrop of the COVID, and since then we are continuing it. Today's lecture is on a very special and important topic, authorization versus authentication, and that too in digital age, to understand the challenges. And friends, all of us always remain confused that what is authorization, what is authentication. Dr. Ritika has just now told you the background of the same. In fact, we need to understand that what is the difference between authorization and authentication. Authentication is something that if M.N. Huda is trying to pose himself as M.N. Huda, is he a genuine person and is he M.N. Huda? That is the authentication. But if I wanted to do some activity, I wanted to undertake some transaction, am I authorized to undertake that transaction? Am I empowered to have that transaction? Have I been given that authority to do that transaction? That is in a simple word is authorization. But in digital age, their challenges are very high, for which all of us are here to understand that Mr. Girish is going to enlighten us different perspective, different dimension, and of course the challenges that in digital age, how are we going to take care of authentication and authorizations. So thank you so much. Keep joining our webinar and keep attending lectures. Keep yourself active, vibrant, and keep learning despite disruptions all across us. Wish you all the best. God bless you all. Over to you, Dr. Ritika.
Thank you, sir. With this, I would first welcome amongst us our expert, Mr. Girish Kapila, sir, with an e-bouquet. Welcome to the session, sir.
Thank you. Thanks, everyone.
Sir is a seasoned senior developer specializing in programming and designing web-based systems with a focus on clean code. He has over 2 decades of experience and has honed its skills in software design and development of large-scale applications and has collaborated with large organizations as well as startups. He has currently worked as an architect at WebGility. Before that, he has also held various roles of technology at HCL, Blue Yonder, Accenture, and a few startups also. Outside his work, he also enjoys learning about space and music from kids as well as watching cricket. His technical prowess extends to various domains, also including cloud native systems. We are honored to have you amongst us, sir, today, and I would now request you to kindly enlighten the house.
Thanks a lot, Ritika, for a warm welcome and a kind introduction. And hello, everyone. Good evening. So let me start sharing my screen and we'll get started with the presentation. Is my screen visible?
Yes, sir.
Yep. Okay, great. So digital ages authentication and authorization, or authentication and authorization in the digital age, right? That's a mouthful. So why did I pick this topic? So as part of my role, right, I work with a lot of engineers to simplify things for them from a programming aspect and whether technical aspects. And one of the topic that often comes from a complexity aspect is authentication and authorization. Let I think, did I lose the sharing?
Yeah, we can't see your screen, Girish.
Okay, let me reshare it.
Yes, sir. Now it is visible.
Okay. Sure. So let me repeat, right? As part of my role, I speak to a lot of engineers, and generally this topic comes up. What is really authentication and authorization? And partly because this is a challenging topic, we find conflicting information on the web when we actually try to look up for the definition and related concepts. And if you look at it, there are a lot of technical jargons, right? So the goal really of my talk today is basically to simplify the jargons, and so that I hope you'll take away something from this talk. So with that, let me introduce myself. I'm Girish. I have close to 2 decades of experience, primarily in programming and distributed applications and designing maintainable and scalable code. So I currently work as an application architect at WebGility, which I recently joined. And prior to that, I worked for startups as well as enterprise organizations like HCL, Blue Yonder, and Accenture, to name a few. And my tech stack includes primarily Microsoft tech stack like ASP.NET Core, C Sharp, and SQL Server, which is a relational database, and few non-relational databases too. And in addition to that, Azure and containerization. That's my kind of core area where I've been working on for the past 19 plus years. This is my LinkedIn profile. Feel free to follow, connect. We can chat. I also post some of the times on my social LinkedIn wall. Feel free to follow if you like that content. Enough about me. Let's get started. So what is authentication, right? To start with, verification of user's identity for system access. What does this really mean? If someone is saying that they are someone, we need to prove it in some way, right? And there are centralized authorities that issue some kind of tokens, or we can actually call it some kind of documents to make it a little more practical, to actually confirm that the user that who he's actually saying is he really that user or not. So verifying that is part of an authentication process. So once the user proves what he says he is, he says he is, the next step is actually about granting access rights to authenticated users within a specific system that we are talking about. That is actually authorization. So there are actually several things that I wanted to cover from a why aspect of it. Why do we really need authentication and authorization? Before understanding actually the what part of it, it's really imperative for everyone to understand why do we really need it, right? In the context of building SaaS applications, like software as a service applications to be precise, on the web, right? Because we have a lot of distributed environments these days, like there are client applications, there are web-based applications, and with the advent of cloud, the systems are becoming distributed. So some of the categories that we see here, like security, right? What do we really mean in the context of authentication and authorization? What is security? So preventing unauthorized access and protect sensitive data. So if we are building a SaaS application, we don't want to let it everyone be into the system, right? We should be able to identify who is accessing our system. At least a basic use case is to know who actually is logging into our system, and we should make sure that the user feels that there is an isolated environment for him within the system, and he can come and work with his data and log basically. While that's the use case from a business perspective, the equally important aspect of security is protecting his sensitive data. Imagine you are just showing a different user's data for someone who is not supposed to see. That's where things start to get interesting, right? I mean, if we are building something at a scale of SaaS and people do not actually get the security aspect of it, that really means the SaaS application is not compliant with specific security measures. Next thing is control. Okay, it's not about just security and protecting the sensitive data, right? There needs to be some way or some measure to be able to provide access rights to the users within that application. So that is the reason we need authentication and authorization, wherein some admin user comes and says, okay, there are a bunch of users that are accessing my system. I should be able to give them granular access. It does not make sense if it's an all or nothing access. There needs to be some control in place. And if we look at it from a different perspective, right? I mean, my website is getting a lot of traffic. Primarily, I serve for a specific location, but I start to see the traffic coming from a different location altogether. Do we have some monitoring in place to measure that? That's the kind of control that we are talking about, right? There should be some control in place when we are building a SaaS application so that we should be able to monitor and have a centralized location to provide access permissions. What is compliance? So security is a broad topic. Authentication and authorization takes some part of this broad topic, right? So what is compliance in that context? Compliance talks about once you have sensitive information like passwords and all are stored, is there some kind of policy, access policy, or a measure to be able to debug and troubleshoot whether a specific data is stored in a compliant way from an authentication and authorization perspective. To give an example, right? GDPR is a broad topic like general data protection, right? Which in European Union it's a big thing, wherein privacy is a big concern. But in the context, sorry, was there a question?
So we'll take the questions at the end.
Sure. So from a compliance standpoint, right, we need to ensure that whatever data that we are actually gathering from different users, it is stored in a compliant way. When someone comes from a third-party audit perspective, and we actually look at the data and someone has administrative access over the data and he's just trying to update the passwords or changing the passwords of the users, just that he has an admin permission, there should be some kind of audit or some measures in place so that we don't leave the SaaS system on the whims and wishes of a specific administrator who has all or nothing access, right? So that's where compliance plays a major role. What is integrity? Integrity is about ensuring whatever the user is signing up for as part of the registration into our SaaS application, he is able to store his data and able to retrieve his data in a reliable way, right? I mean, it's if the user starts to see inconsistency in the way he is able to access a SaaS application, that's where he kinds of does not rely on a specific system. And that's where the next point comes, which is trust. Without all these measures in place, right, the end user typically look at our system and then see he's starting to see different behaviors within the system. He starts to lose trust, and that's not good for the business, right? And that is the reason we need authentication and authorization. That's the excuse me, need of the R from a SaaS perspective. So now that we have understand why it is important to ensure authentication and authorization is in place within a SaaS application, let's get rid of some differences, right? Authentication and authorization has a very thin line. As Professor Hodasar was mentioning, it is actually imperative to understand what is actually the difference. So authentication comes at the very beginning of the life cycle of the application, right? I'm taking this from a hotel, for example. I'll take that use case, right? When I actually uh, arrived at the hotel, the first thing I did was reach out to the reception and I showed my identity, right? Before actually trying to access my room, which comes as part of authorization, I actually uh, presented myself at the reception, and the receptionist just looked at me and said, I don't know who you are. Just show me some kind of proof so that I can verify that you are who you say you are. So I had to pull out my PAN card or Aadhaar card. That is a proof of identity that I have just given to the receptionist, and he's able to validate that by looking at my face and comparing it, and he just handed over me the access key. So that's basically authentication for you, right? In very high level simple terms. Again, let's going back to the goal of my talk. Let's try to simplify the technical jargon as much as possible. That's the goal of the talk. So that's a practical simple example. So verifies the identity of a user or entity. So proves one's identity to gain access. Now that I have gained access, ensure the user is who they claim to be. So the person at the reception just validated whether I am actually the person who say who I am actually. So in the context of a SaaS application, right, that's basically the passwords, biometrics, and security tokens. We talk about, again, these are jargons. I don't want to just get ahead of myself. So these are examples of some of the technical terms that in the context of SaaS application, this is what we do. We present some passwords, biometric or tokens. And for that matter, there are additional factors that we can look at as we go through this talk. As I said, typically it occurs prior to authorization. As I mentioned, I just don't go to the room that is allotted to me before actually presenting myself and prove who I am. Next come the authorization, right? Now that I got the access key because I have proved who I am actually allowed to go into a room that is designated for me. I cannot just go into someone else's room. That's where the authorization concept comes into picture. So it is about controlling the access once I'm in the hotel so that I don't mess around with the hotel system. I don't want to go to the kitchen. If I don't have a gym subscription, for example, I don't want to mess around with the gym. But just that I just have access to my room. That's the authorization in the very simple terms. But when it comes to SaaS-based system, right, it's called role-based access control. So let's give an example from a system perspective. I have let's say employees and managers in an organization, right? As an employee, I can look at my self data, right? I can look at my data. I cannot look at my colleagues' data or my peers' data, right? But as a manager, I might be able to manage a team. So I'll be having access to all my reportees. That's where role-based access control comes into picture, where we are talking about two different roles here, like manager and an employee. There is another kind of access control, which is attribute-based access control, right? Let's take a different example here. For example, you are basically logging into an e-commerce site, right? And you are under 18 years of age, for example. An e-commerce site may have an access control placed wherein you are not supposed to buy alcohol, for example, right? Because you're less than 18 years of age. And this is applicable to all people who has an attribute of less than 18 years of age. This is something called attribute-based access control. And typically this occurs after the authentication process. So this is based on, I mean, once you have the access key and there are specific measures in place to control access on which areas of the system that you're trying to access. So this is the difference between authentication and authorization. Okay, let's understand with an example, right? Throughout this talk, we'll revisit this application. This is a very simple application to make the concepts really simple, right? Let's look at an application called FitTrack. So we are building this awesome software as a service application in cloud using the latest and greatest technology. So what this app does is basically very simple thing. It just enables the user to look at different free slots that he has uh, to work out basically to track his fitness routine. And whenever the user comes, logs into the system, it says, okay, Monday 8 p.m. you need to do a routine, and Wednesday 5 a.m. you need to do some jogging, and Saturday 3 p.m. let's do a strength workout or something else, right? So user can just follow the schedule. And I understand from a domain perspective, it's not pretty complex, but the idea is to make the domain so simple so that we can focus on the core aspect of this talk. Okay, so this is the use case that we are going to talk about, right? So sorry, I clicked on something. Okay, so we are asked to build an authentication for this app so that we, as a developer, as a developer, we are asked from the product manager for this SaaS application. Let's ensure the user is actually able to log into the system. We don't want anyone just to come and access, because we'll not be able to differentiate who is accessing our system, right? So we need a basic authentication in place. So as a developer or a technical lead, we looked at this. Okay, let's do a basic authentication. Let's not get ahead of ourselves and build a complex solution, but let's first understand what is basic authentication, right? So basic authentication is something wherein the user will try to access the FitTrack application in our case, and he'll be presented with a browser pop-up saying it is generated by the browser. That's the key, wherein he needs to enter a username and password, and then he'll be able to access our application. It's as simple as that. Okay. From a technical nuance perspective, the credentials, which in this case are username and password, will be sent as a clear text to the server. That's what is basic authentication, but let's look at it as a workflow here. Okay, this is fittrack.com. The user has visited fittrack.com by opening the browser. Okay, then he sent a request. The request basically looked at the server basically looked at the request. In this context, right? Our SaaS application is deployed on this server, which is backed up by database. So the user's username and password are stored in this database. So the user has sent this request, and the server looked at it and say, does this have a valid authorization header present? In this case, in the analogy that we looked at in the hotel receptionist, right? The user came to the hotel and the receptionist looked at, do I know you, basically? No, then it says, okay, I don't know who you are. Can you please let me know by asserting your credentials? Though the terminology is little misleading here, it says 401 unauthorized. That's why it's very vague, or the developers will find it very difficult to understand the concept. Basically, it's saying you are not authenticated. It's not about authorization here. Okay, you asked me to prove who I am, and he says, okay, I'll submit. Basically, when this response came in, the browser looked at it and, okay, the server is asking me to authenticate. Let me present a dialog to the user, which is a browser pop-up with a username and password. So the user has entered username and password, and he submitted the request. And now let's look at a happy path case wherein the server now looked at the authorization header and it sees some credentials in the form of a base 64 encoding. We'll talk about what it is. It's again a technical jargon, right? Okay, it says it validated with the database. Okay, I know who you are. Okay, let me grant you the access. So it responded with 200. Okay, these are kind of status codes. If you have experience with APIs and all from a web perspective, uh, if I'm talking to a technical audience, this is kind of status codes where 400 series stands for the client needs to take an action. In this case, client is made aware that he's not authenticated, wherein a 200 series is it's all good from a server perspective. I'm responding, you're all okay to access the application. These are all the status codes here. But encoding, we talked about encoding, right? Let me little bit elaborate about that technical jargon. Encoding is not equal to encryption. Let me spend a little more time. So computers understand zeros and ones. It's all binary, right? Those are the fundamentals of computer science. But HTTP is a text-based. It's hypertext transfer protocol. It's text-based. It understands text. So the process of converting this binary data into some ASCII code is called encoding. I mean, there are different forms of encoding, but this is what HTTP understands. So when it is presented, the server can then decode and look at what are the values actually. But this is not encryption, right? Encryption is much more complex, and that itself requires its own talk. We cannot justify this time to talk about encryption, but most of the developers I talk to, there is a confusion. They think that encoding is same as encryption, which is not. That's why I'm emphasizing on it. Partly that confusion comes from the data that is getting obfuscated. It will not be shown as plain text, but it is shown as some gibberish, so that gives a false impression that this whole transit, the data in transit is basically secure and it's all encrypted. Since this is not encrypted, right? And one of the important thing that we need to consider when we are implementing basic authentication as a developer of a SaaS application is to ensure we always do it on HTTPS. It's not just true for basic authentication, it's true for any kind of authentication. We'll look at other types in the next slides, but that's basically a mandatory thing to move the sensitive data like username and password over a TLS, so that someone just putting a hole in the network and trying to sniff the data, they'll not be able to see anything, even though it's passed in the header as a plain text. Now that we are transitioning this data over a TLS tunnel, they'll not be able to see that data. So that's about basic authentication. So tying it back to our use case, now we are able to accomplish whatever our product owner or manager asked us to implement. Okay, our FitTrack application has now basic authentication in place. Okay, let's look at the drawbacks, right? What are the drawbacks of basic authentication? With this use case, what we are essentially doing is we are transitioning these credentials to the server on each request. Okay, that's annoying to the users. It's not a good experience. Whenever I visit fittrack.com, you're presenting me with some pop-up. I'm entering my credentials. Okay, there are some additional screens on FitTrack. Whenever I click on any one of it, again, I'm presented with a pop-up. That's kind of annoying. That is one of the drawback from a user experience perspective. And the whole experience is all does not also gel well with the pop-up that we are seeing while we have created some niche UX using some top JavaScript applications and CSS frameworks. The browser pop-up does not gel really well with the rest of the screens. So these are the two drawbacks that we see. And let's continue with our example with additional requirements that we get from the product owner. Next, what he says is, okay, all good. You have given me an authentication mechanism, but this is not it. We want to improve our application. Our login form should match with the rest of the user experience of the application. And also, user does not need to enter the credentials often. I want to simplify things for the user. I know you are trying to make the application secure, but we need to make a trade-off, right? We cannot make it at the cost of user experience. That's where another kind of authentication that comes into picture, which is forms authentication, right? With this, what happens is the user clicks on fittrack.com, our awesome SaaS application. Again, he's trying to access the application. He sends a request. This time, the application detects that the user is not present in our system, similar to what has happened in basic authentication. But this time it's not gonna respond. It's with a 401, but it says, okay, I kind of found a resource that you are looking for. But now that I don't know who you are, again, please present yourself, your credentials. Going back to our hotel example, right? But this time it's not going to be a pop-up. Now, browser is not made aware of any information from the server in the response header, and it does not know anything about showing a pop-up. So it just let the response go to the application, which is our client application, which is a JavaScript or whatever. And here the user now is presented with a beautiful screen that matches from a user experience perspective with the rest of the application, and is presented with a clean user ID and password form wherein he enters his user ID and password and clicks on login. Again, he sends this request. Similar to the previous request, some data will be sent across to the server. Now, here is the change. The web server, just like the other scenario, it validates whether the user is existing in our application in the database. And now what it does is it creates a ticket. Uh, Remember, we also need to solve, in addition to the user experience challenge, we don't want the user to log in multiple times into that pop-up, right? And that's where it says, okay, you need not send me the user ID and password every time. I am stamping you. You have logged in once. I'll issue a ticket to you, so that next time if you present me with this ticket in your next link, if you within the same session, before actually going to something else or accessing some other application within the same session, if you are trying to access this other parts of the application, you need not send me the user ID and password. I know who you are already. So to understand who you are, I'll send you a ticket. With every request, you send me back the ticket so that I trust you. And that's what it does. So, okay, I'm redirecting to a protected URL with ticket. This black thing is a ticket. I'm not sending the user ID password anymore. And web server checks for the validity. And one important thing that we need to look at is this ticket is not valid forever, right? I mean, there is some expiry that needs to be associated with this ticket so that it's not valid forever. Otherwise, if someone else is trying to access on the user's behalf after a week or so, he should still be able to prove himself, his identity, right? That's where the expiration comes into picture, another technical jargon, right? So we'll just expire the ticket on the server side as a developer in the code so that it is not valid forever. But in this case, I know who you are. You presented me a valid ticket, so I'm responding again with a status code of 200, and the use case is served. So this is about forms authentication, right? But let's look at some of the drawbacks. So the ticket that I spoke to you in the previous slide, this one, uh, this is also sometimes called cookie, which is stored as an authentication ticket in the browser, and relying on it is not a very secure way of doing things. That's a whole different talk, and that comes under security. But just to give a high level, there are some vulnerabilities that are associated with these session cookies. One of them is cross-site request forgery attack, right? Just to brief about what it is, this vulnerability. So let's say the user has already proved himself by providing the user ID and password in his first login attempt, and he's returned a ticket from the server. And he's still in that session. He received an email meanwhile from a malicious user with a link, and he's interested. The user is interested to click on link, and he clicked on it. And it opened on a different tab within the same session. It opened a browser, but the browser thought, okay, the user is in the same session. So with every request, I'm just going to attach a ticket. I don't know where he's sending this ticket. So it attached that ticket. Now this malicious user has created some logic in the application, in the link where the user has clicked. He received that ticket. Now he posted that ticket to an actual website. He's kind of impersonating the actual user, right? And he's trying to do something that is not intended to be done, but by impersonating just by using the ticket. So there are ways to solve this issue, but it's kind of putting some pressure on the developer again to ensure this vulnerability is mitigated, right? So these are kind of drawbacks. Other drawback is primarily this is for web browsers. And in future, if we want to create this application from a mobile app standpoint, not all mobile apps support cookies. And that's where, from an architecture and design standpoint of SaaS application, we are stuck. So these are few of the drawbacks. Now let's continue with our example, right? So user should now be able to sign in with his social login. When I say social login, let's say a Google login or something, a Microsoft login. The reason for this, the second point explains, right? Till now, the application is actually just showing some slots to the user, or maybe potentially reminding him during those slots. Boss, you need to do this during your slots. Your workout routine is basically planned during these slots. Don't miss on it. But the user might be busy during the slots, and he's actually managing his calendar on a different application like a Google Calendar or Microsoft Exchange Calendar, right? And the application doesn't know anything about these external applications, and it might just provide him the slots where he want to perform his workout routine, and potentially he may miss a lot of slots, not a healthy experience for the user. So what the product owner, he has evaluated and he came up with a new requirement. Okay, I want you to look at the user's calendar, primary calendar that he uses either for his business or his daily work routine. Look at that calendar and identify what are the free slots and then provide the workout routine in those free slots. I don't know how do you do it, but this is my requirement. And in future, I want to also be able to do it on a mobile app, convert this application to a mobile app so that it's easier for the end user to be able to track his routine on the mobile app. Right? These are valid asks from the product owner, and also in future I might need a multi-factor authentication. Again, another technical jargon, right? Let's understand what is multi-factor authentication. Okay, so one of the I would say categories through which I can prove who I am is by providing my username and password or a security pin. Uh, just the way these days mobile apps are locked with pins, right? Just like that pin. So this is one category, right? And the other kind of category where I prove myself is, in addition to maybe username and password, there is a hard token or a soft token. Let me give you some examples, right? A one-time password that is received on your mobile. That's another way of proving yourself in addition to your username and password, right? And the third way is biometric. We briefly spoke about in the initial slides that user can be authenticated using a facial recognition or maybe providing his iris to the application. That is another way of providing or asserting who someone is basically. If you look closely at these categories, right, this username and password and security pin, you will memorize it, right? You'll not write somewhere. In some cases, you may write it, but you get my point. You just try to keep it in the memory. That comes under the knowledge category. This is something you are aware of it, right? You try to memorize. Suppose, for example, you go to ATM and you put your debit card, it asks for a PIN. So you memorize your PIN and then you enter it to get the transaction done. That's one example, right? And when it comes to OTP, right, it falls under a different category. If you receive an OTP, suppose in the same example of going to ATM, right, there is a two-factor authentication implemented where you need to enter a PIN, but also you need to enter a mobile OTP that is received on your mobile. But you cannot memorize your OTP, right? It's a one-time password. It's just for one single use. If you forget your mobile at home and you get an OTP, you cannot actually enter the value by just memorizing it. You need to have a device you need to possess. That's where the possession category comes here, right? And the third one, you don't need to remember anything. You don't need to possess. It's your quality, right? You are basically authenticated based on who you are, basically, from a quality aspect. Only you have the quality, which is like iris or your facial recognition and all. These are the categories, and these are the factors using which you build your SaaS application to make it more secure. Okay, so because this is important because security is always dependent on defense in depth, right? No matter how secure you make your system, attackers will always find new ways to make your system vulnerable. So it's always better. Remember the trust keyword in the initial slides. If you make your system uh, vulnerable, the users will lose trust on your system and they'll leave to your competitor. You don't want that. You want to make sure the different factors and defense in depth is baked into your system so that your system is reasonably secure And this is called multi-factor authentication. And remember, if you use a username and password in a combination with a security pin, both fall into knowledge category. It's still a single factor authentication, though you are making the user enter two different values in two different screens, because it's not cutting across the categories. It is called multi-factor only if at least your application picks from two of these three categories, right? You enter a username and password, and also your system sends a security code either through to your mobile or some other device, then it's truly multi-factor. So now that we got rid of one other technical jargon, let's move ahead. Okay, now you got the requirements from your product owner. Now you want to implement the Microsoft or Google Calendar thing where you want to access the users basically calendar data to be able to uh, provide the free slots. That's the ask. So you thought about it and you thought, okay, let's it's very difficult. I don't know how do I get a user's credentials. The only way I get user's credentials is by asking the user actually about his Google or Microsoft Exchange credentials. Let's create a login screen and ask him to enter his google.com credentials, right? And let me move this aside so that you can see the full screen. Uh, so if you closely look at it, we are asking the user to enter his google.com credentials here. It says @google.com. It's not @fittrack.com. User has already logged into fittrack.com using the application's credentials. Now that we need access to his calendar also, we asked him, okay, please enter your Google or Microsoft credentials here, because without the access to your calendar data, I have no way to actually provide you with a free slot. So I promise you, I'll use these credentials only for the purpose of accessing your calendar data, but I will not send some spam using your credentials to someone. I'll not access your email. I'll will not delete your contacts. You should trust me because I promise you, I'll put a disclaimer, right? So how many users will sign up to your system if this was the case? If you think about it, again, it goes back to the trust aspect, right? Your users will not trust your application because you're asking them to enter some of their personal different application credentials, all in very good intent you're asking, but user cannot trust your system simply because it gives away uh, the credentials to a kind of it opens up Pandora box, right? I mean, a lot of people have a lot of Google sign-in authentication for a lot of systems. Once the user provides his Google credentials, that's it. You will have access to everything. You might have good intentions, but remember the super admin that is actually storing the information in our database, he might not have the good intentions, and he may store it in plain text and take it and do whatever he wants with the end user's Google password, right? So this looks promising, but this is not the kind of system that you want to build. And why I am emphasizing on this point, because without standards in place previously, the systems have been built in this way. And not to pick on those systems specifically, but there were no, or the standards were absent previously. So the developers or engineers did not have much of a choice but to follow this kind of architecture or a design. But let's see what are the drawbacks of this. We have followed this approach primarily because it's a very difficult approach or a design to build a homegrown authentication system. That's very evident and apparent from the previous things, right? Because the requirements are evolving. We started with a basic authentication, and then the requirements evolved further. And it says, no, I don't want a pop-up. I now need a login form. And again, we iterated on that requirement. We created a niche UI and created our own login form. And then now the requirements really started to get interesting, and it started to get out of control. There is only so much we can do with homegrown authentication systems. Uh, we don't know, the security standards may change in future. I mean, the complexity of passwords may not be of length of 8 characters anymore. It might involve some complex rules which are difficult to contemplate in a SaaS application, because we need to focus on our business of FitTrack and building an awesome FitTrack application. If we end up focusing all our energy on building a secure system, that's not our niche, and we may lose our business to the competition, right? So now that it is started becoming evident that this is difficult to build a homegrown authentication system and managing these ever-changing security requirements, and building a complex delegated authorization solution, that's another technical jargon. We'll talk about it in the next slide, what it is, but these are some of the drawbacks in the existing system, right? So what is delegated authorization, right? Remember, the requirements are to get the access to the Google or Microsoft Calendar from our FitTrack application, and there needs to be some way of getting that without actually sharing the credentials. That's where delegated authorization comes into picture. So some really smart people, they actually they formed a team and thought, okay, with the advent of iPhones, mobile phones, and this is no more a problem of a Windows application or a client application. The technology and the problem space is really evolving, and we need to create some standard basically to ensure all this is addressed, right? And there should be a standard in place so that developers need not do random stuffs or do some hacks to work around these things. That's where OAuth, there is a OAuth 1.0 but for all practical purposes, it's deprecated. If you're building anything new, you should follow OAuth 2. And that is the standard that is created by a group of smart people so that we address this delegated authorization problem and kind of decouple this whole authentication and authorization from the actual application space so that we can reason about it in a much more simpler terms from a developer's perspective. So one of the things delegated authorization or OAuth 2 does is it gives a fine-grained access control to the application. Let's talk about by going back to the previous slide, right? We spoke about this. The application needs calendar info, so there needs to be a scoped access that needs to be provided to this client application. So that one of the challenges is I don't want this application to go and do some additional stuff like deleting my contacts or sending some spam. It needs to be a fine-grained access that is scoped to only reading the calendar info, not even making changes to my calendar. So let's define a scope there. That's where the scope terms came in, right? So it defines the scopes of access to granted the client application. In this case, it's our FitTrack application that enables the fine-grained control over the resource. When we say resource, it is actually the user's Google Calendar info in this case. Okay, and there is a delegated access, right? So we need to allow users to grant access and without able to share their credentials. That's bad. We already understood why sharing Google's credentials to FitTrack is a bad practice. So there should be some process to do that. So giving the fine-grained access at the same time, not giving the passwords to some random third-party applications like FitTrack. And there are some grant types. Today we'll not have time to cover all the grant types. This is basically a large topic, and again, uh, in simplifying the overall talk, it's not looking at the time constraints, we cannot talk about all, but there are grant types like authorization code grant, implicit grant, which is deprecated now, and there is client credentials, and there are other grants. But today we'll focus on authorization code grant, right? And there are a lot of tokens, access token, refresh token, and ID token, and these are all some of the topics that we are gonna spend some time on, right? So let me give you an overview without with that previous slide. So now FitTrack tries to access Google Calendar. How does it look like now? So the application should provide a sign in with Google button. That's what the engineers decided to do. And basically it redirects when the user clicks on sign in with Google, it redirects to accounts.google.com. And if you closely observe, the domain is .google.com. It's not fittrack.com anymore, which was the case in the previous scenario. And at least now the user is trusting the application because he's giving away his email and password to google.com, not fittrack.com, because the user has been redirected to Google. And once that is done, right, the Google looks at it, okay, FitTrack is trying to access or redirected this to me. The user has not entered google.com. The FitTrack, it came from an application I know, which is registered with me previously. And it says to end user that, do you want to really allow the FitTrack app to access your calendar info? This is where the user is provided with a yes or no option. And the user can say no, which usually means nothing interesting happens and the flow ends here. FitTrack cannot get the calendar info. But in the event that user clicks on yes, because he knows that he is giving access only to read the calendar info, not to do anything else, he clicks on yes. Yeah, I like the FitTrack app and it will be much more beneficial to me if they can read my calendar data and provide much more useful use cases to me. So then Google goes back and redirects to fittrack.com to a specific URL called a callback URL or a redirect URL because your user has consented yes, and I'm now redirecting back to fittrack.com. And this is where fittrack.com, okay, I got redirected to this URL. Now I'm gonna call calendar.google.com now, and calendar.google.com will get a request from feedback.com now, and it says, usually I'll not give you any access if you are a random app, but now that user has consented and you are now coming to me for asking his calendar data, not any data, just read access to the calendar. I'm gonna give access to you. And it provides you the access, and that's how we'll fulfill the use case. If you look at in this overall process, we are not sharing any credentials in FitTrack app. It's essentially happening at Google's end, and with a lot of redirections. We'll dive deep into in the next slide how the redirections happen, and we will take a closer look at it. Right. So you might have heard about client, a lot of technical jargon. Again, I'm trying to simplify. Client is nothing but the FitTrack application. In this case, a resource owner is nothing but the user. In our case, in our example, who owns the calendar data. He is the owner of the resource, Google's calendar data. And authorization server, here it is google.com. So Google is determining whether or not to provide authorization here, right? And authorization grant, it's a, again, as I said, it's a code grant that we are going to look at in the next slide. This is kind of a grant that we provide to the application. And there is an ID token, there is an access token. These are all again jargons. And this is a resource server. This is the calendar.google.com server where the resource, the actual calendar data, which is nothing but the resource that client has given permission to. And scopes, we spoke about scopes at length at the beginning. We are actually asking the user to or the authorization to provide access only to calendar.read scopes, not anything else. Let's have a closer look at how it works now. Now the user.
So Girish,
Yeah.
a quick time check.
Yep.
If you can move ahead and.
Sure. Yep, sure. Thanks, Ajay. I'll take 5 more minutes. So with the fittrack.com sign with Google, the client requested, right? And it actually called for a callback. It passed the callback URI, nothing but the fittrack.com.callback. That's how the Google knows I need to redirect to this callback once the user has consented yes, right? And he has entered that and he has consented yes. And this is where the authorization grant has been given. Okay, I am consenting that you can give access. And that's how, since that it knows that it has provided the callback URL, Google knows where to redirect. Hence, it redirected here. And basically it gets something called access token, and this is where instead of password it gets a token, and this is what is used if you can correlate it with a session cookie or something. This token will be used instead of the cookie in the forms authentication case, which is usually expired, and it's supported by mobile apps as well. And it's just nothing but a JSON web token, it is called, which is called JOT. That's how the authentication or access token will be shared with calendar.com. Now that calendar.com, calendar or google.com knows it's an access token, and eventually it fulfills the use case. So looking back, right, this is an enhanced security because the application is not worried about the security aspects or security measures that it needs to implement. And the protection of sensitive information, again, it is offloaded to Google. It's up to a third-party system now with the standards in place. It need not be Google. It can be another authorization server, like an identity server, which is an open source server that can be used as well. But now the application has decoupled that from its SaaS use case. Compliance with regulations, again, this is outsourced to someone who is specialized at security, customizing the access control and improved accountability. So the SaaS need not worry about this with this new OAuth in place. One subtle nuance I would like to talk about. OAuth is about authorization. It's not about authentication. But OpenID Connect is the protocol that came in just to solve the use case from an authentication aspect. Because in the previous slides, we spoke about all about the access permissions, the tokens and all, but people started looking at OAuth as authentication as well, and they started implementing their own hacks. But OAuth did not necessarily contain any information that says it has user information like username, user email, when that access token is exchanged. And again, applications started building their own mechanisms to identify the user information and all. Again, another standard was needed. That's where OpenID Connect came into picture. That is nothing but a thin layer on top of the OAuth practice, wherein it also provides the user information like username and email. It just not looks at the access aspect of it. It also looks at the authentication aspect of it. So OpenID Connect is for authentication standard, and OAuth 2 overall as is for authorization standard. With that, I'll leave it up to the Q&A.
Thank you, sir. Thank you for the wonderful session. I have a few questions which I will now take up with your permission.
Sure, Ritika, please go ahead.
Thank you, sir. The first question we have, how can security be maintained in legacy devices that may not be capable of moving to newer architectures like the cloud and may not even support encryption?
Yep, that's a very good question, right? I mean, it's a legacy system, and it's definitely one of the challenges is it's hard to reason about the legacy code. Uh, but uh, but the essential part of it is the user ID and password. The more we are dependent on storing those, it makes much more problematic in the long run, because we are talking about there are no encryption practices in place, and the passwords and usernames are stored in clear text. So we need to identify to refactor the authentication piece of it, not the entire application, and then decouple it from rest of the system. That's how the refactoring needs to be started. Otherwise, it will be difficult to reason about the whole system and then work on it. We are not moving to cloud here. Even with open source OAuth 2 standard uh, applications, we can actually offload a lot of security to these systems and then let the application focus on a larger refactoring, which will take time. And even if that is not possible and application needs to rely on a legacy login and password, the first step is to ensure implement encryption within our database. We don't want to store plain text user ID and password. And we need to ensure we need to channelize our efforts in securing those areas. So that's how we need to take it up ahead.
Absolutely, sir. So next question we have. Post-pandemic, as employee access crucial systems and data from private devices, how do organizations maintain a high security standard?
Yep. Again, a great question, right? So we have uh, even not post-pandemic, right? Even in pre-pandemic, if an employee is trying to access his Outlook from his mobile device, he's always on the move and he need to access sensitive information in SharePoint or email or whatever, right? So it's typically not, it does not fall under a SaaS application world, but typically the security admins will roll out applications like Intune and all to track the overall usage of the employee with respect to the corporate data, so that there is proper governance in place and the devices are secured enough and not exposed to vulnerabilities. So these applications like Intune will ensure uh, if the devices are connected to vulnerable networks, they'll not allow access to the corporate network. That's how it's dealt with.
Thank you, sir. Thank you for the wonderful session. With this, we come to an end to this wonderful session today. I would now request Professor M.N. Huda, sir, to kindly present a certificate to Girish Kapila, sir, as a token of remembrance for this wonderful session.
Yeah, Mr. Girish, thank you so much for having delivered this wonderful session. In fact, authorization and authentication is always a confusing subject, even for technocrats. But in such a simple way, you have explained that I'm sure now people at least will not get confused. And with increasing and growing challenges because of digital age, this problem may increase. So thank you so much for having delivered this session with all of us on this platform. And this certificate is not for the purpose of certification, rather for the purpose of remembrance that you have been part of this lovely webinar. So thank you so much. And may I have memento, please?
Yes, sir.
This memento is again for the purpose of only remembrance as part of your document at your home. And you might have noticed we have also changed right from bouquet, from bouquet to e-bouquet, from certificate to e-certificate, and from memento to e-memento. And once we are moving from physical mode to virtual mode, authentication and authorization requirement is very high. So thank you so much for enlightening us. We'll meet again. Over to you, Dr. Ritika.
Thank you, sir. And thank you, Girish, sir. Thank you once again for this wonderful session today. With this, we come to an end to this wonderful session. Thank you, sir.